Well, climate change is one of the critical issues of the 21st century. And one way to measure climate change, one of the most common ways, is to look at what's happened simply with global temperature. Now, over the 21st century, there hasn't been much change yet, but in the 20th century, temperatures rose about 1.5 degrees Fahrenheit when averaged across the entire planet. You might wonder, has that temperature rise been steady or unsteady? Because carbon dioxide, the main greenhouse gas, has increased a little bit every year. So you might think temperatures also would be rising a little bit every year. In fact, there's been quite a bit of variability, both from year to year and then over periods as long as, say, a decade or two. Let's look at a graph of temperatures over the last century or so and go into that in a little more detail. As you can see in this plot from the National Oceanic and Atmospheric Administration, temperatures have been rising over the last century, but it's divided into several periods in addition to the year-to-year jumps that you'd expect through events like El Nino. The main transitions have been around 1910, where you can see temperatures began to warm across the globe. That peaked in about 1940, and then from the 1940s to 1970s, temperatures actually dropped slightly, and that was mainly because of some cooling in the northern hemisphere, and there were quite a few rough winters, especially into the 1970s, that had some people worried that an ice age might be setting in. But then starting about the late 1970s, greenhouse gases continued to increase, and temperatures also began to rise quite sharply, and continuing into the 21st century, although the rise in the last decade or so hasn't been too intense. It's been fairly level. Well, now that we know that temperatures didn't rise exactly the same way every year during the last century, you might wonder, what about geographic variations? Have the temperatures been rising at the same rate everywhere around the globe, or have there been variations across regions? The answer is yes, there have been. The northern hemisphere has probably seen some of the largest increases. Part of that is because the north part of the globe is where most of the land across the globe is. If you take the equator and go south, there's a lot of ocean. Up here, there's a lot of land, especially in Eurasia. So anything that's going on with temperature, whether it's rises or falls, is going to happen a little more quickly where there's land, because land warms up more quickly than water. So let's think about regions and what happened during that cool down in the mid-20th century. That was really focused in the northern hemisphere, and especially in places like North America, Canada, United States, Europe, Russia. There were some extremely harsh winters, especially in the 1960s and 1970s. And there was a lot of talk about a possible ice age. Well, something else was happening during that period from the 1940s to the 1970s, and that was the explosion of global industry, especially in the developed countries of North America and Europe. These places were putting out a lot of the kind of pollution, aerosols, that block sunlight. This is gunky, dirty air that obscures the sun, causes sunlight to reflect, and it's not good for us to breathe either. And starting in about the 1970s, environmental control started to put a lid on those aerosols, so the emissions from developed countries went down. But from about the 1940s to 70s, there were a lot of aerosols being emitted from these developed countries in the north. And that's exactly the same time when that part of the world was cooling the most quickly. So it's now believed that it's those aerosols that put a lid on global warming during that period. Even though greenhouse gases were increasing, they were getting an even more rapid increase in the dirty sun-blocking pollution. Okay, so what's the bottom line after looking at all these regional and temporal variations? Well, unfortunately, climate science is complicated. That's one thing that becomes clear. Temperatures don't warm steadily every year, bit by bit. Instead, there's variations over years to decades, and also variations from region to region. Now, one nice thing is that by using computer models, we are able to simulate what happened over the last century, even down to the point of why certain regions of the planet have warmed more than others. And those fit really well with what we know about where pollution was happening, how industry developed after World War II, and even how the sun increased in intensity a slight bit during the first part of the 20th century. All those things are folded into models, and together they do a really pretty good job of explaining how the warm-up evolved from place to place and from decade to decade. Now, it's going to be a trickier job to predict the next century and how the warming will evolve, but models can give us some clues. For example, we know that the Arctic is the most likely spot to have really severe warming. So that's going to put a lot of things like Arctic sea ice at risk. So another take-home message is that when you hear about things like scientists predicting global cooling in the 1970s, you have to take it with a grain of salt. There were a few scientists who were featured in magazines like Time and Newsweek who were very concerned about the aerosols and recognized that these aerosols were probably helping to cool some or all of the planet. However, even then in the 1970s, there were a lot of scientists concerned about global warming. And in fact, one scientist published a paper in 1975 saying that we might be on the brink of a global warming produced by greenhouse gases. So even in the 1970s, there was a lot of concern, and in fact, a study recently found there were more scientists who published about global warming than global cooling, even as the globe was going through this cool period. So that's a sign that really, for about a century now, scientists have known that greenhouse gases are warming the planet, and we have to sort of look at it as 2 steps forward and 1 step back. The planet may not warm every year. It might even go through 10 years or so with steady temperatures as we've had in the first decade of the 21st century. That doesn't mean that global warming is gone. It doesn't mean it's not going to warm up again. So we have to take the long view when we look at this problem.